Hello. Hi, everyone. 안녕하세요. Hi, I'm sorry for my bad pronunciation. My name is actually Alicea, and I am an evangelist for media and entertainment at Unity Technologies. I am based in San Francisco, California, but I am from Dorado, Puerto Rico. I've been an indie game developer for the past 10 years or so, and I'm super excited to be here at Unite Seoul with all of you. It's really awesome to be able to get to know you all the cool things that you're working on, and I hope that you all have been enjoying the talks at Unite Seoul. In particular, I'm really excited to talk to you all today about how to get started with shader graph and HDRP. Now, in this talk, what I'm going to overview is what exactly is Unity shader graph and the HD render pipeline. I'm going to talk about shader creation basics, how to get started using shader graph. Then I'm going to deep dive into some examples and use cases of more advanced shaders using the HD render pipeline. And then lastly, I'll share some resources that you can reference for when you go home and start making your own awesome, amazing shaders. Sounds good? Great. Now, out of curiosity, who here has used Unity shader graph before? Raise your hand. Okay, a couple of you. So for those of you who haven't gotten familiar with shader graph yet, it is a really awesome node-based system for creating shaders in Unity with no coding required. So those of you who here has just programmed shaders in general, with or without shader graph. Okay, a couple more of you. So those of you who program shaders are familiar with having to do all the shader code and everything that you need to create your shaders. Now you can do it visually. So, however, for those of you who do program and who do shader scripting, the shader graph is extendable, and you can use things, you can access properties of shader graph through your scripts in Unity. Now, not only do you not need to know how to code to use Unity shader graph, but it also gives you really great visual feedback as you're building your shaders, so you understand what you're doing step by step throughout the process. Now, what shader graph does is that it auto-generates shaders for the lightweight render pipeline and the HD render pipeline. So this means that it doesn't create shaders for Unity's original built-in renderer. And it has also a built-in node library with an API coming in the future that you will be able to extend and do more with. But for now, let's take a look at what makes up the basics of a shader graph. So first, you have your master node, what's highlighted here in green. This is where your final shader is going to be represented in your shader graph asset. Now, if you've worked with materials in Unity before, you may be familiar with some settings like albedo and metallic and so on. So you'll find all these settings also here in your master node in shader graph. Now, some master nodes are render pipeline specific. So things like the unlit and the PBR master node will work on both lightweight render pipeline and HD render pipeline. But some of the nodes I'll be talking to you about today work for HD render pipeline only. Master nodes like lit, stacklit, fabric, and more. Now, you can only have one master node per shader graph. And another cool thing I like about master nodes is that, let's say you built your shader, but you really kind of want to see how it works. You can right-click on the master node, and you could actually view the shader code that it's generated. Then you could take that code and add more to it or edit it, and then use that separately as a shader in your projects. Now, a master node without these input nodes here is nothing, right? So these nodes are what you chain together to create your final shader effect. Now, they display a visual flow of your shader as you're adding more and more nodes to your project, and there are hundreds of nodes that do many different kinds of things. So here we just have kind of two visual examples of how the shader is looking like, one with our texture and one with the final shader. But if I went ahead and added more nodes, let's say to change the color of that texture to green, and then to add an emission color. With each node I add, I can see how each step will affect that image towards the final shader. And you guys will see more in an example that I'll show in a bit. Now, you can combine nodes to create subgraphs that you can use and reference in future shader graphs. So let's say you're creating a shader and you find yourself using the same 4 nodes for a similar effect that you want to achieve often. You can actually take those 4 nodes as a group and save them as one subgraph node, and then you can use that subgraph node in your shader graphs and future shader graph projects. Now, there's also a custom function node. For those of you who know shader programming, that you can add the node to add your own custom function. So this is kind of the option that we have for you guys to add some flexibility to your shader graphs until the API comes out. But by using this custom node function, you can add your own shader script directly through the UI to help kind of tweak your shader to be exactly what you need it to be. Now here in the left is the blackboard. So the blackboard is where you host all your properties in your shader graph. Now the blackboard is special because you're not just hosting your properties like colors that you're using or textures or more, but anything that is in the blackboard can be referenced through your inspector in the editor. And if it can be referenced through your inspector, as many of you know, it can be referenced through your code, through your scripting. So any values that you expose in your blackboard for your shader, you'll be able to see them visually in the Unity editor without having to open shader graph. Now, why would you do this? So for those of us here who work with teams, who work with artists, who work with people who don't work on shaders, this is a great opportunity to allow them the ability to edit and tweak these shaders as they need without having them open the shader graph and fiddling with all the different settings and get confused to try to get what they want. You can directly provide them access for things. For example, let's say you're making a racing car game and you want to create different shaders for your race cars. Instead of your artist having to go in and make a shader for each one in shader graph or edit the same shader multiple times, they can just use the shader graph inspector settings, add in their own images or change the colors through the inspector, and then they're done. So it's a really convenient way to work with your teams using shader graph. Now here on the bottom, you have the preview node. So the preview node, kind of like the master node here, shows a final preview of what your shader is going to look like. But a really cool tip I recommend for the preview node is if you right-click it, you can actually see different meshes that you can test your shader on. And you could also use meshes from your own projects. So let's say you're creating a shader for a character in your game. You can directly preview their mesh in this preview here to see how the shader's overlaid. So this prevents you from having to jump back and forth between your scene view to your shader graph to figure out how it looks. You can just get a final idea of how your shader's going to look right here in the preview node. So some big news about shader graph recently that we shared at GDC 2019 in San Francisco. So shader graph is officially out of preview in 2019.1. So what does that mean? We often get questions, hey, what does it mean when something is officially out of preview? So really what we're saying now is that shader graph is ready to be relied upon for production use cases. Now, we're not saying that it's going to have every single feature that you're going to need it to have, and you can make anything you want now. It's already. What we really mean by that is that we're not going to remove features for future releases. We're going to have a clean upgrade path, so you don't have to worry about making something in your shader and then losing it in the next update. Essentially, it's also more stable with a lot more bug fixes, and the bug fixes from now on, now that it's out of preview, are handled the way standard bug fixes in the editor are taken care of. Now, this also means that there's a long-term support for shader graph as well, with at least a minimum of 2 years of support for critical fixes with each version. So what about HD render pipeline? How many people here, raise your hand, have worked with the HD render pipeline before? Okay, 1 or 2 people. 3, 4, you guys are awesome. All right, so HD render pipeline essentially targets high-end PCs and consoles to prioritize stunning, gorgeous HD visuals for your Unity projects. Now, this is for apps, games, experiences, for devices running on GPU compute. And really, these are going to be your multi-core PCs and your consoles. So if you're working for something like mobile, let's say you would use the lightweight render pipeline. But HD render pipeline's focus is creating insanely gorgeous visuals, kind of like the Heretic. If you guys saw the keynote yesterday, you saw a great example of how the HD render pipeline was used. And really, the HD render pipeline ties into shader graph by giving a shader graph access to those special features of the HD render pipeline. Now, I'll jump into examples for that in a bit. But how do you get shader graph? How do you get this set up in your project? Well, it's super easy. You could do it by using the package manager. I think this is my last question now. How many people here have used the package manager before? Okay, a lot more people. So a bunch of you are familiar with it. For those of you who haven't used the package manager, you're definitely missing out. This is a way to get easy access to all the different tools and features that Unity is working on, whether they're in preview or out of preview and more. Instead of, for example, in the past, having to go to the GitHub page and cloning the repo, bringing it to your project, now you can just download it directly into your Unity project and you're ready to go. So to use all the things that I'm going to show you today, you'll have to download the shader graph package to the package manager and the HDRP package as well. But now it's more fun for me to jump into the editor and show you how to use shader graph than just talk about it with some slides. So let's get started with a live demo. So I want to turn PowerPoint off. Let's see. We did it. Cool. So here I have just a basic statue model, so we could just keep it nice and simple and you guys can understand what's happening for the shader. Now, when I meet people who are, attempting shaders for the first time, one of the frequent questions that I get is, hey, I'm working in a game and I want to make something like a damage shader. Like, when you're playing a game or like a platformer game or kind of any game and your character falls or gets hit, it starts flashing red with damage. That's the kind of effect that we're going to go for with this shader. And I'm going to show you how to achieve it with just a couple of nodes in shader graph. So how do we do this? Well, we create a new shader graph in our project. That's really simple. We go to our projects folder, and we can right-click, create. If I had my glasses, I could see it better. Let's see. Shader. And then we have PBR graph, subgraph, unlit graph. We have many different options for the types of shader graphs that we want to create. In this case, I'm just going to make a PBR graph because this example that I'm going to show you is a basic example, and it will work for lightweight render pipeline or HD render pipeline. This is just so you guys can get the idea of what we're achieving. Now here I have my blank shader graph here. I have my PBR master node right here on the side. I have my blackboard for my properties here on the left. And we're going to start adding some nodes to affect how this statue is going to look. So to add a node, I can just right-click on my graph and select Create Node. And I could search through the hundreds of nodes. They're filtered through different groups and sections. Or if you know exactly what you want, you could just type it out also in the search bar. Now in this case, I want to apply kind of like a glowy rim effect to the shader. So the first step I'm going to do is add a Fresnel effect node. Now, you can see here in the preview that I have kind of like a white glow coming in from the edges towards the center of the object. In shader graph, if I zoom in here and adjust the, there we go. I'm zoomed in as much as I can. All right. So if I change the power of the graph here by just clicking and dragging the X value, I can adjust the Fresnel effect to be at the intensity that I want it. In this case, I think this looks good right here. This is fine. Now I could plug this in to my shader. I'll plug it into the albedo and into the emission for my shader. And now if I press Save Asset, I'm going to go look back at my shader, but you're going to see that we're not going to see a difference because the Fresnel effect color is white and my statue is white. So if I look at it here, it looks the same. So what do? Let's add some color. So I can go ahead and add some color by going to the properties in my blackboard. I'll press the properties button and I'll select color. And I'll choose my default color to be a nice bright red color for our damage shader. Now, once I have that, I can go ahead and grab this color property and drag it into my shader graph. And it's as if it were its own node that I can work with. Now, how do I combine this red color with the glow effect? By using a multiply node. So I'll right-click, create node, search for multiply, and I'll go ahead and combine my two properties, my two nodes into the multiply node. I'll delete these two connections here, and I'll plug in my multiply node into the albedo and into the emission as well. So now that's done, I'll hit Save Asset. I'll go back to my scene. And you see that now I have a red tint on my statue. Now, this is the base first step, right? But I want to create that kind of like flashing damage effect that I can use in my game. Going back to the shader, it's really simple. I can add a time node. I can have my, my Fresnel effect be affected by, let's say, a sine time. So if I create a node and add time, each of these different options will have many different effects. One of my #1 recommendations for creating with shader graph is to just add different nodes and plug things together and see what kind of cool, crazy things you can create. But in this case, I'm going to plug the sine value here into the Fresnel effect. And you'll see in my preview, I can see that it's flashing here. And so I know that's the kind of flashing effect I want to achieve for my statue. So if I save that, go back to my scene, you'll see it has, now it's getting more intense and then going away and more intense. And I could access this property later through my code and adjust how maybe fast I want that flashing to happen, or maybe have it happen at a certain time. But in this case, one thing I also want to add is that, let's say my character gets too much damage. I want it to have a kind of a knockout effect and have it kind of evaporate away. Also super simple to achieve by adding a noise node. So you can use nodes like simple noise in many different ways to achieve many different effects through shader graph. In this case, I have this noise node here. I'm going to adjust the intensity of that grain that I have for my noise. I think this looks good. I'm also going to add, and I can drag out of this node as well and let go to have it automatically link my nodes for me. I'm going to search for a step node. And essentially what's going to happen here is that it's going to almost roughly make like a height map, so to speak, of my noise values, which will then affect my final shader output. Now I'm going to link this over into the alpha clip threshold for my shader. And one more thing that I'm going to add is a slider value to help me adjust how I want that noise to appear on my texture. So I'm going to create a node and add a slider. Now I'll take this slider, I'll drag it into my step node. And now if I drag the slider, you can see it changes the intensity of the noise I have for my shader. Now if I kind of add it toward, keep it here in the middle, I'll hit save. I'll go back to my scene, and you see that now it's applying that noise as an alpha clip value onto my shader. But let's say I'm working with someone who wants to be able to reference this through the code for a character dying effect. But I didn't add it to my properties to make it accessible. So like here in the color, because I have exposed checked, anybody on my team can just access it through the inspector because it's exposed. But with the slider here, I can just right click, convert to property, and it's automatically added as a property in my Blackboard for me to reference. So I just make sure that exposed is checked. I save my asset. I go back to my scene view. We see the flashing happening. And if I open my shader properties, we see here the color value that I can use to change the color. And we see here my slider that I can use to affect how I want my character to fade away. And now if I want in my game to just be like, oh, my character died, I can just have my script go, whoop, dead. So that is how you create a simple shader with just a few nodes in shader graph. So look, 1, 2, 3, 4, 5, 6, 7, including the master, and we already have a cool shader. Pretty cool, right? So now I want to jump into some more in-depth examples of how to use shader graph with the HD render pipeline. So the first example I want to show is, and I'm going to go away from my statue here now. Where's my grass? Here we go. All right. So here I have 2 grass examples. Now, who here has seen Unity's Book of the Dead project? Have you guys seen this before? A couple of you. So Book of the Dead is a project that uses the HD render pipeline. It takes place in a forest, and you have lots of natural-looking trees and grass and more. So what we did here for this example and several others that I'm about to go through is that we grabbed the HD render pipeline shaders from those projects and recreated them in Shader Graph to show you that, one, you can recreate these amazing HD shaders using Shader Graph, and two, by doing so, you can add a bunch of cool custom behaviors and features to your shaders as well. So here on the left, I have this basic grass shader that we grabbed from the HD render pipeline Book of the Dead project. But here, we have the Shader Graph version. And what we've done here, if I go to my influence sphere here, if I go and move this object, you see that it also moves the grass, and it's burning the grass as I'm moving the object around here. So how are we achieving this? Through Shader Graph. Now, let me go into the Shader Graph and show you what it looks like. Now, as you create shaders, your graphs become a little bit more complex and more complex. But not to worry, because if you actually look at shader graphs often branch by branch, they often tend to make a lot of sense. So if I go here to this kind of middle branch, focusing on over here, I'll bring this up so you guys can see more. There we go. So here in the middle, what are we doing? So I'm getting the position of that sphere that I was moving around. We're using the distance node here to get the position of that sphere, and we're using it to calculate what we're calling an influence sphere by using the add and the 1 minus and the clamp nodes to create this kind of like sphere effect based on that exact position of that sphere. And so what we're saying in this shader is that anything that's within that radius of that influence sphere, we're using this branch up here to get the position of each of those blades of grass, and we're telling the shader to push those blades of grass down their Y value. So here we're getting their original position, and then we're grabbing here we have a property that we're determining how much we want to push it down the Y value, and that's adjustable in the inspector here through my properties. And then we're creating alert for those values so it can animate between the two. And we're plugging that in here to our lit master shader. This is a HDRP only shader node. So we're affecting the vertex position of the blades of grass in the project. And if I go back to my scene, you see now if I adjust the influence amount more, that sphere gets bigger, affects more of the grass. And I could also change the area colors. So maybe I don't want the grass to burn. Maybe I want it to be just really green or blue or whatever kind of effect I want to achieve. Really simple things that you can do in Shader Graph that add a lot more interest in things you could do than just having a plain HDRP shader. But we get the same exact cool visuals. Now let's go to the next example here. I really like these. So those of you here who have made shaders before, y'all are familiar with things like grab pass and use pass, right, for your shaders. So this is a way to grab essentially we're using the scene color node to grab pretty much what you see on your screen in your project as a texture that you could use for your shaders. So this is a new way to use it. Instead of using grab pass and use pass, you'll use the scene color node. Now in this example here, what we're doing is that we're grabbing the scene color from anything behind this plain game object I have in my scene. So, and if I kind of change my direction, you could see it affects, if it's visible behind that plane, it'll be affected by the shader. Now let's take a look at the shader graph for it. Really simple, really, really simple. What I'm doing here is using the scene color node. I'm grabbing that scene color from behind the game object. We're splitting it, and we're using step to grab the colors and divide them to be two colors, black and white. Then we have the black and white split amount property, which allows us to adjust the intensity of the contrast of our image. Then we have it going into an invert colors node to invert the colors, which go into a branch that has a property that will allow us to reverse those colors through the inspector if we want to, because it's an exposed property here in our scene. And then we plug it into an unlit master node. So if I go back here and go click on this shader, remember that like black and white split amount to adjust that contrast? If I edit this slider here, you'll see it does that right here, right through the inspector. Or I can just click that check mark for that clamp value and invert the colors. So there are different ways that you can use these scene nodes. One thing I like is that some of the things I've done as a developer also include just doing art for games. And doing that, I got to learn a lot of different image editing tools and processing software. A lot of the nodes that you can use in Shader Graph are actually really familiar to things that you might see in these image software. Nodes like posterize, which take the color values from the scene color node and reduce the amount of hues that are displayed in the shader. And we also have, and that's just one node. We also have this is a popular favorite one in the office right now, the twirl node. So the twirl node just takes, so it doesn't just take the scene color, it also grabs the scene UVs and it applies a twirl effect to them. So as we're zooming in and out, it's twirling our scene here through the screen. Really cool for making it think like a portal or like a time warp or something. Let's take a look at it here. It's 3 nodes. It's a really cool effect in just 3 nodes. So we're grabbing the screen position and we're plugging it into the, for the UV values in the twirl node. And we're essentially just twirling it. We have a property to adjust the twirl amount. And then we just plug that into our unlit master node. So if I go back here and go to my shader settings, I can adjust that twirl amount right here. So really cool, really fun. Now, let's take a look at another cool thing about using HDRP and Shader Graph. Now, here we have 2 examples from Unity's FPS sample game. Now, these 2 flowers are in this project, in this multiplayer shooting game. And we have on the left the original shader created in HD Render Pipeline. And on the right, we have the Shader Graph version of this shader. So they both look almost exactly the same, except you see that we have cool effects happening on the berry of the plant. And we're achieving this by using subsurface scattering, which is a feature unique to HDRP. Now, the best way I can explain it is by kind of zooming in a bit and going over here. So subsurface scattering is basically the effect of light going through an object and bouncing around and then exiting to create kind of more natural organic lighting effects. So this is really good if you want to do something like skin or things like plants and more, and you don't want it to look really plasticky or fake. So by using subsurface scattering here on the berry, you can see it on the one in the back here and here in this one. Notice how the tip is a lot brighter because it helps create like kind of like that juicy berry effect. We're achieving that by enabling subsurface scattering through the HD Render Pipeline. So now in Shader Graph, I actually want to adjust the values here for this shader so you can see the different cool things we could do. So here what we're doing is through my properties, we're plugging in all the different textures that we're using. And we're also plugging in a subsurface mask and a thickness map. So the thickness map is the image texture that we use to let the subsurface scattering know, essentially, which areas should have more light passing through them. So I'll double click it here just so you can see briefly as an example. The wider an area is, the more light is passing through it. So if I go to my shader graph, here we have the breakdown here. So we have the texture that we're using for the base of the plant. We have our normal maps. We have our subsurface masks, and then we have here our thickness maps. And now one thing special that we're doing here to show you the different ways that you can use this is that we have our thickness map, but we're also multiplying it with a Voronoi node. This just creates a randomly generated kind of cell-like looking noise effect. Like kind of in my earlier example, I used that time node to help my shader kind of pulse. In this case, we're using a time node, and we added some properties that we can use to customize how we want the time to affect that noise. And now we have the noise moving around. We're multiplying it with our texture here. And so you could see in the plant berry, the light for the subsurface scattering, or the light, the thickness, is being moved around and adjusted throughout the berry here. Now if I go to the settings and I adjust the cell speed or the cell density, you can see it's affecting those properties and affecting the berry here. Now to kind of help you understand like my example of like, why would you use subsurface scattering, look what happens if I turn it off. Like the berry just kind of looks very plastic and not very organic. But by adjusting the settings, we can create kind of a more natural looking effect. All right. Here's another one I really like. So this is another example that comes from the Book of the Dead. So this is a bush that we're using to demonstrate how you can use diffusion profiles to have kind of a more organic feel as well. If I go to this bush here, let's see if I can click on it. There we go. So if I go here and I look at it through the sun, one thing you could see is that you see the light passing through the leaves, going through, creating that more natural looking effect. The leaves are of different colors. They're not all like one like solid green color. We're using the HD render pipeline to achieve that lighting effect. Now, we're doing the same exact identical thing here in this example, but we're adding some cool features to it using shader graph. And you'll see that there's a common theme that I'm mentioning for the different shaders that we have for examples here. So if I go to my settings here for my bush, now I can change the color here. So now they're identical, but you see here through the color blend property here that I have activated through shader graph, I can adjust the color of the leaves. So let's say in my game, if I want to make it so that's fall, I don't have to replace all these random foliage. I can just use my shader and change the color blend. But in fall, the leaves fall to the ground, right? Well, I can do that as well by adjusting the vertex position of my leaves. And these are all things that you can achieve through shader graph. I can change the tint color so I can make my leaves more orange or yellow if I want. You guys get the idea, all the different things that you could do through shader graph. And this is the graph for this one as well. Again, really simple. It's really, I just love how you can just add so much more to your HD render pipeline shaders by using shader graph and not have to do so much work to achieve these cool effects. Now, here's another example. Now, we actually grabbed this example here from the lightweight render pipeline because it's actually really easy to grab shaders that you make in LWRP and bring them over into HDRP and adding some more cool effects to them. So in this case, if I zoom into this boat here, it's subtle, but if I kind of go in maybe where the light shines here, here we go. You see those like little speckles here, and that's a kind of like car paint effect. We're achieving that using the brand new coat node that is HDRP specific through Unity Shader Graph. It helps us create more kind of realistic metals or plastic effects and so on. So we're using it here for the paint in this boat. If I open my settings for my shader, I can get very specific on how I want this coat node to behave. I can adjust the coat mask, the kind of like the gloss that's applied on the outer edges. I can adjust the smoothness of how smooth I want the light to bounce off of this coat node. How metallic I want it to look. Maybe I want like a really chrome looking boat. And I could even change the colors and more. One thing I really like about this example is that we're actually taking this texture here of the boat. We're plugging a texture just like this. It has the blue colors, the red, the green. And what we're doing is we're dividing this texture through shader graph. And we're using each channel. And we're actually tying them to specific color nodes through the properties. So that way, I can go into my scene here. And I could change. So anything that was blue in that texture image there is the base color of this boat. So in this case, it's green. I can just go ahead and make it a red boat. And I could go ahead and change the stripe to, I don't know, I don't want to make it like a Christmas boat. Here, greenish yellow. I don't have a lot of sense of style here for colors, but you get the idea of what I'm trying to achieve. So this is a cool way to add different variation to your shaders to save you time. Kind of like that racing car example I mentioned. You don't want to make like 10 different textures for your racing cars, make one base one and then change the colors through shader graph for each one of them. Now, let's see, what else? What other cool things do we have? I like these. These are really cool. So these are, these statues here are using something called the stacklit node, or master node, I should say. So now, one thing I want to preface here is that this may not be the most performant of the shader graph HDRP nodes, because if I go over to it here, you can see it's a lot bigger than my other nodes, right? What a stacklit master node does is let me stack all the HDRP effects that I want for my shader into one node. So some different types of materials that you may work on may need to have those extra kind of settings combined. So we can do this through the node. So if I go to my options, you can see I have a whole checklist here of things I can activate or deactivate for my shader depending on what I need. So I can adjust I can add coat, I can have iridescence or transmission, I can add decals to receive subsurface scattering and more. In this case, we have the metallic, or rather we have the iridescence one activated, the decals, subsurface scattering, geometric specular, and more. And really what we're doing is that we're stacking these effects so we're able to use their properties to make this cool glass looking node. And we're able to achieve it by stacking all those effects together. Now again, not the most performant depending on your situation, it can be, but this is how you can achieve some effects for things like glass and leather. Has anyone here seen or used our our new materials library that Unity has released? Oh, I'm excited I get to tell you guys about this. So Unity released a library of about 100 plus shaders created in Shader Graph. And these are actually using those materials. So we grabbed those materials, those shader graphs from the material library and just added them to our statues here in HDRP, and it just works out of the box. Those shaders, and I'm going to share a link to them at the end of my presentation. They're available for all of you to reference, to use in your projects and more. So this leather one here, this is for our car. And we're able to drag that in and apply it to our statue, and we have a cool leather statue. Same thing here with this lovely sweater effect. Although I'm not sure if I would wear like a black and orange checkered sweater, but you get the idea. Here I have this kind of, you could see like the fuzziness here of the texture. Same with the chrome here on this statue here. And these are all unlocking the power of the stacklit node and the material libraries that we have available for you for free from us at Unity. Now, I'm going to show you these final two nodes here in the back. Now, here we have fabric nodes. So we have two different fabric nodes here being used in this project. We have a silk node and a cotton wool node. And these allow us to create kind of more realistic, natural looking fabric effects. So if I go to my silk shader graph, you see here if I scroll here, I'm using a fabric master node, which is one of the new HDRP only nodes. And what I'm actually doing here is I'm using a subgraph. So you remember I mentioned earlier in the presentation that you can make groups of nodes to create a subgraph. We created a subgraph specifically for us to be able to determine the details of the threads of the fabric. Because no matter what kind of fabric you're working with, it always has threads, right? So it would suck for each and every fabric shader that I want to make the same exact thread, behavior. I could just save it as a subgraph and use it in all the fabric shaders that I want to use. So we've done that here. We have a subgraph here that helps us determine the strength of the thread, how many threads we have in our fabric, and more. And again, this is a really big graph. I'm not going to spend time going through each and every node. But what we're doing here is that we're giving us the ability to, and I'll zoom in here so you can see a little bit better, to go to our properties in our shader and adjust things like how smooth we want the fabric to be, the normal map strength of the embroidery. If we want to have, let's say, like make a tapestry with really intense noticeable embroidery, we can just adjust the normal map values for it, and we can see it looks more intense or more soft for like a really nice screen printed maybe silk pattern effect. We have the thread map texture here that we're using, so if there's a different thread map texture that you want to use, you can just replace that 2D texture. We can adjust the thread strength. So if you see, if I make it, you can especially see it in the shadow there. If I bring up that intensity, you can see the more like bumpy knottiness of the fabric. The here you can see it as well with the thread normal strength as well, kind of upping that thread count to be a more coarser fabric. And same with the fuzz map, the fuzz map, the fuzz strength, how fuzzy, how much lint, right, do we want the fabric to have? This is all achievable through shader graph. Now, same thing here with the cotton wool node. If I go to its settings, same exact deal. It's almost the same type of shader, but by using different colors and different textures, we're having a different effect here for that fabric node. And so yeah, so these are kind of rough examples of how these shader effects can be achieved through shader graph. You can see there's like a lot of different ways you could do it, and these are all just kind of like quick examples that you can that I've been able to show you right throughout this presentation. But think about something like the Heretic. A lot of those cool effects were achieved by using things like shader graph. So you can create some really advanced, complex, cool effects using these tools in Unity. I have 10 minutes left, so I'm just going to wrap up, so there's time for questions. So to recap, so shader graph, it's a node-based system for creating shaders for the lightweight render pipeline and the HD render pipeline in Unity. It's available now through the package manager in Unity 2018 and above. And it has an extensive node library that is extensible, and you get your code output. Actually, you know what? I actually do want to show you guys that so you can see what I'm talking about, because it's pretty cool. So if I go to one of my shaders here, I'll go to the grass influence one. Where'd you go? Here we go. So if I go to the shader, that's here, and I right-click my master node, I can just click Show Generated Code. It'll open up Visual Studio for me. And here I have my entire shader graph code that has been generated by my shader graph. So for those of you who do shader programming, like this is a perfect tool for you to use to understand how these shaders work and start making your own shaders based off of this information. All right, back to the last slide. If there's any slide you want to take a picture of, it's this one here. Resources for all of you. So the Shader Graph HDRP Nodes project, we're making this available for you soon to reference for your own projects. And also Shader Graph documentation. For those of you who need documentation on how Shader Graph works, even down to how each node specifically works for your projects, you can reference them through that link. That materials library that I mentioned with the 100+ shader graph effects that you can use for your own projects can be accessed through that third link right there. And the shader graph lit master node overview and sample project, if you're really interested in this, this is the #1 thing I recommend for you to read. This blog post here is a deep dive into how to create super gorgeous visuals using shader graph and HDRP step by step by creating a project that looks just like this one here. So we have this nice butterfly bonsai tree here. If I press play, you'll see I have the nice, like the beautiful iridescence coming through the tree. Many of the effects that I showed you today are being used in this project. The butterflies, they're flapping their wings. That's not an animation. That's everything here is done through Unity Shader Graph. We're doing vertex animation for the butterfly wings. We have special HDRP iridescence happening on the wings as well. This could be a whole 2-hour+ talk if we wanted it, but we have a full guide available as to how we made this project. So that last link on my resources slide is exactly where you can learn how they achieved this. But that's all the time I have for now, so I hope this was all helpful for you all. Shader Graph 5.9.0 is out now for you to be able to use all of these tools. And thank you so much.